Yes, class. So let us start now. Let us start with the class. Yeah. So maximum range we have covered. Only one or two things are left in this chapter. Let us quickly complete this chapter so that laws of motion can be completed, because laws of motion is coming in your exam. So I want to complete that before your exam start. So I hope till laws of motion only it's coming. Any other chapter is included. So please update me about that, because I'm going according to laws of motion as the target for the next. If there is any other chapter, otherwise they'll increase the class. Anyways, velocity at any instant when we have to calculate. So Vx we have, Vy we have. So Vx plus Vy, Vx is what? Ux plus axt, right? Now acceleration ax, this is 0. So Vx is simply ux. That's it. Here you do not have the concept of cos theta, right? You have not resolved the vector. So this is not cos theta. You're just writing it simply Vx is equal to ux. Now when we are coming to y, along y-axis, Vy plus Ayt, right? Now Uy is 0, Uy plus Ayt. Basically, V is equal to, our main equation is V is equal to U plus At. This is our main equation. So along a y-axis, when we are calculating anything, then this will be Vy plus A by T, right? So Uy is 0, Ay is T. So this is our final equation when you write Vy, this is equal to Gt, right? So when you are calculating the net velocity, it is simply Vx plus Vy. So when you are calculating the magnitude of this, it will be simply under root Vx square plus Vy square. And when you are calculating the direction tan beta, it will be simply Vx by Vy. That's what you have to remember. We'll see one question to start writing from here, class. Right, now see this question says, an aeroplane flying at an altitude of 100 meters with velocity 10 meter per second. It drops a packet. Now, if the helicopter is moving, it drops a packet. Now, if anything is being dropped by the helicopter, so that particular packet or that object, that will be acquiring the same velocity as that of the helicopter, right? That gives you a hint about the initial velocity of the packet. We have to find out the time taken by the packet to strike the ground. We have to find out the maximum horizontal distance covered by the packet. And third, velocity with which it strikes the ground. Now, aeroplane is flying at an altitude of 100 meters. Velocity is 10 meters of the aeroplane. Now, if this food packet is being dropped, it was dropped because of the helicopter, na? Helicopter was moving, so the packet is being dropped, right? So it means the initial velocity is 10 meter per second. Height is 100 meters. So what is the formula of time? 2 under root 2. Height is 100 by g is 10. So root 20, but in the exam, if it's not mentioned, you cannot take g as 10. Okay. Maximum horizontal distance means what? Range. We have to find out the range only, right? So initial velocity, that is 10 into simply the time, which is 10 root 20 meters. Lastly, velocity with which it strikes the ground. So Vx, first Vx is equal to u, Vy is equal to g. So this is 10 meter per second. And this is 10 into time is root 20 meter per second, right? So when you are calculating, you will calculate under root x square means 10 square and Vy means 10 root 20 wholes. This much meter per second will give you the magnitude, and similarly you will get tan beta for the direction. Vx by Vy simply you will write down the question. Those who were asking to show the question again, I am showing it. Now I'll scroll from here. Let me know any doubts. That completes with this chapter. I'll start with laws of motion. Major portion already we did in the previous classes.
Ma'am,
Yes, Alina.
ma'am, my unit tests start on 11th. First one is physics.
11th August.
Yes, ma'am.
Okay, and what's the syllabus?
Ma'am, this motion in a plane.
Alina, please text me in the chat column properly the syllabus with the date.
Okay, ma'am.
Also, one more thing, class. I have been constantly asking you all from the past month regarding your syllabus. I have got this much only information that till laws of motion, it's coming till September, whoever is getting the exams. You people do not inform despite constant asking. So then it becomes difficult. I would have taken extra classes then. Anyways, Alina, please mention the syllabus.
Ma'am, I send you.
Okay, then no issues, Alina. If even if it's from 11th, then motion in a plane and motion in a straight line are only coming. Both the chapters are done. Right. So just study them and let me know whichever portion you are facing issue in the numericals, in the theory part, so that we can have practice session. I thought laws of motion is also coming and then syllabus is pending. That's fine then if it's coming. We can have our extra classes separately, one to one, Alina. Just revise, study. These portions have been done. This is covered till here. Let me know whichever issue you are facing. I'll take your extra class. I'll give you practice questions. Just update me and let me know.
Okay, ma'am.
Done.
Noted, ma'am. All right, class. So now the next chapter that we have, this is Newton's laws of motion. We have to, the next chapter that we have, this is our chapter 4, which is laws of motion. Now see, in the previous classes, whatever we were studying, we were just studying that if a vehicle has started the motion, vehicle has started moving. So vehicle will just move, velocity will be there, a particular displacement will be covered, right? That is what we have discussed. If the acceleration is this, velocity is this, then what is the displacement? Only these types of questions we were dealing with. Now, that kinematical portion is over. Now the issue that arises is, if the velocity is 3 meters per second and the car is covering a displacement of 5 kilometers, why is the car moving? If the initial velocity is there, let it be. Why did the car move? Right? Why, with the help of the velocity, the car started the motion? The main question here is this. Understood? So any answers for this? Velocity is there. Velocity is not letting the car move. Right? Velocity is a quantity which is present initially and finally and throughout. Right? Similarly, displacement is also being covered. Still, why are we focusing on something which is known as the laws of motion? Or you can say, why is the vehicle moving? Any guesses? Any idea? See, basically, here I'll tell you. Here we deal with in this chapter, we deal with the cause of motion. Not only a single cause, so it's better if I say causes of motion. So we'll be studying about the causes of motion. Now we'll focus if the car had a particular velocity and the car began moving and there was a certain displacement covered and all. The car moved because the velocity was there and acceleration was there, which led to the force. And force ultimately allowed the car to move forward, backward, or stay at rest. All right, so this term which we have, force, this is ultimately our cause of motion, which we have to study in this chapter. So laws of motion is all about forces. So initially when we started with units and dimension, that was a general chapter, leave it. Then we studied motion in a straight line. In motion in a straight line, we just had velocity, initial velocity, final velocity, those three equations and all. When we came to chapter 3, motion in a plane, one more quantity increased. What? One coordinate got increased because it was a two-planar motion, right? Now in laws of motion, one more quantity is being introduced, which is the concept of force. So we'll be talking about in detail about and learning about what is this force, this quantity, this term, which is known as the force. Fine. Now, the first concept, Newton's laws of motion. I hope you have studied this laws of motion in your 9th class already. All the laws of motion, but in bits and in little details you have done. Now you will be studying the entire story in detail and you will be figuring out things by yourself. Now the first term that we have is inertia. This is a little theoretical part. Inertia is actually the completely theoretical part, not a little theoretical part. See, this inertia term, inertia basically means if you are in some state. State means what? This is not that state. Suppose I am in Delhi, not that state. State means 3 states we are talking. State of rest, state of motion, or state of a particular direction. Understand this first. These are all theoretical topics, so you have to pay a little attention in the class. Everything is there in the notes. So you will get plenty of time to copy down things, but you have to pay attention here first, right? Now, state of rest means I am sitting here. All right. I will always stay at rest if no external force is coming or any other external forces allowing me to stand or pushing me to stand, right? Suppose I have the muscular force. My muscular forces are allowing me to stand. That is the external force. External and internal is not defined by our within the body and outside the body. What is internal, what is external, that also I'll tell you. First, focus on that. Or forget me. We human beings have muscular forces. So yes, that can be sometimes considered as internal force. Forget that. Usko bhi chodo. Take a non-living object, a ball. A ball is kept on the ground. You have kept it at a particular point on the floor. Suppose this is the floor which is present. In this floor, you have kept a ball. And what you are doing, you are marking a boundary around the ball. That is, you have drawn an outline around the ball to check its position. Okay? You have taken a ball, you've put it on the ground, you've marked an outline, marked a boundary, and 10 years have gone, 20 years have gone, you are coming and you're seeing the ball has not moved. Even if you are increasing the time, let's make it 200 years, let's make it to 200 years. If no external force has been touched towards the ball, or no external force has touched the ball or moved the ball, whether it's 10 years, 20 years, 1 second, 2 seconds, 10 minutes, 1 hour, or 1,000 years, the ball wouldn't move on its own. Correct? Why? Because this body, our body, or any body, this has a tendency to stay at that state. Obviously, there is no engine within the ball that the ball would move, right? And ball is non-living, so it does not have this concept of muscular forces also, right? So that is the state of rest in which ball kept. Now, this is one case. All right. Second case, second example, just pay attention here. Second example is you have a sliding board, and that's very, very huge. Let's say this is so huge. Hypothetically, we are talking, so let's say it is infinitely long. You have thrown a ball on the tip of, or you can say on the starting point of that incliner, and you have left the ball. What will happen? Ball will move down. Through that inclined plane, ball will move down, move down, move down. And since this is infinitely long, it will always continue to move down only due to gravity, right? How can it be stopped? You stop it. Any external force, suppose wind has been blowing very strongly, so that has let the ball move. That is external force. You have stopped it voluntarily. That is external force, right? So this is another example, right? Now one more example. Suppose there's a fan, let's say. Fan is basically, okay, fan has this electrical property, so we can say we can switch off the circuit. Let's leave the example of a fan. Or let me just tell you, if something is moving in a circle, it is moving continuously in complete state of circle, 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 and till the time external force has not occurred, that body will continue to move in that circular path only. Why? Why cannot it move in a straight line? Because there is no external force present to move its path. If there is a centripetal force, okay, centripetal forces we have not done, that we'll do in this chapter only. So if there is a force which is present, and that force has shifted that ball, so that ball which was moving in a continuous circle now moves in a straight line. But till the time this external force was not applied, what happened? The ball was moving in a circle. So 3 examples we have studied. In the first example, one ball was kept on the ground and it always stayed at that position. In second case, a ball was moving down an inclined plane and it always moved through that incline. In the third case, the ball was moving in a circle and it continued to move in a circle. Now, this property, not the force, pay attention class. This property of the body, this entire property, this entire example which we are discussing, which I have told you, which we are discussing, this is called inertia. It does not mean this external force which can shift the ball or which can move the ball from the ground is called inertia. No. You put the ball on the ground, the ball stayed at that position. That property is called as inertia. Because many students have this tendency to answer that inertia is the force, or due to inertia the body moved. No, inertia is just a property. Property, the term property is different and the term forces are different. Do you get this difference? Property means characteristic, a property of something, right? When we say force, force is actually a physical quantity. Force is not a property. So when we are talking about inertia, inertia is this inability of the body to change all these states which we have studied. And by the states, we mean state of rest, motion, and what? Direction. These are the three states which any body in nature has the inability to change it. This term, this was given by this inertia word, this was given by Galileo. And let me read all the things which I have written. Now, if any doubts in between, please stop. So term was introduced by Galileo. It's the inability of the body to change its state of rest or uniform motion by itself. It's the property of the body, not force. I have written it in brackets and make this point important. And it depends on the mass of the body. More the mass, more the inertia. This is the property of inertia itself. Now, this is clear. Tell me, inertia is clear. So Newton's first law is automatically clear. Ali, clear? Alina, Abir?
Ma'am.
Yes.
Yeah, ma'am.
All right. Yeah. So Newton's first law when I'm talking. So if I'm talking about the Newton's first law, that is known as law of inertia also. When I say Newton's law, first law, you can always call it law of inertia. Basically, whatever we have studied in understanding the concept of inertia is your Newton's first law. That no body can change its direction or motion or state of rest without any external force being applied. This concept of external force just gets added, added to the definition of inertia, which we call this and say this as the Newton's first law. So let me show you this. So it in Newton's first law, this is also called the law of inertia. This is the law of inertia, because sometimes law and class, if I am teaching this theoretical part, it means this is not just for the understanding purpose. Questions do come. So do not just ignore the portions which I have taught you right now. So yes, it introduced the concept of force. Body will maintain its inertia, means its state of rest, state of motion, state of direction. Body will maintain its inertia unless an external force is applied on the body. If a ball is moving, if a ball is rolling on the ground, if I put my foot on it, it stops. That is the external force, right? So external force can change inertia of the body. And what are the types of inertia which we have studied? Inertia of rest. Body tends to maintain its state of rest. Means if this is on the ground, let's say a ball is there. T is equal to 0 seconds, the ball is here. Even after T is equal to 1 hour, the ball will still be here only because of inertia. Inertia of motion, or best example, you forget this. Look into a more relevant scientific example. If you are sitting in a bus and then the brake is applied, the brake of the bus is applied, what happens? Bus has stopped, right? When we are studying, just a second, class. Yes, class. So we were discussing inertia. So if a body, let's say we are sitting in a bus, all right. So continuously we were there in motion, right? Bus was moving, we were moving. with the bus. Moving with the bus means we were inside the bus and sitting, and we were also moving along the bus. Now the brakes have been applied and the bus has stopped. Bus is now at rest, but still, or in a bus, what you take the example, you are sitting in a car, you tend to your upper body, this tends to move forward like this. When the brakes are applied, as soon as the vehicle stops, your body moves a bit forward like this. A jerky movement is there. Why? Because your lower body, which was in the along with the vehicle, has stopped, but the upper body, which was in motion, remains in the state of motion, and that's why we feel this jerk. So that is a good example. When you are moving, when a moving vehicle stops. One more example, you see inertia of rest. This is inertia of motion. Inertia of rest का example देखो. If you were there in a bus was moving, your body became in the state of motion, right? Now you have jumped out of the bus to get out, right? You are on the ground, you can just stop moving, you can just stand straight, right? But since our body was having a tendency to stay in motion, even when we should come at rest, our body tends to maintain that state of motion. So we move a little, right? So body tends to maintain state of motion. One more example is when you jump out of a moving bus. Right? Jump out of a moving bus. So all these examples are there. And inertia of direction means in absence of external body, body will move in a straight line. Means if a body is moving in a straight line, for this to complete a circle and go in this direction, there has to be some external force acting in this direction. This is all what is all about the Newton's first law, which is important. Start writing. Any doubts, please let me know.
Ma'am,
Yes, Alina, say.
ma'am, what is t is equal to in that diagram?
This is t is equal to 0 seconds. This is 1 hour. Actually, I just wrote it as 1 second, so I made it 1 hour. This is just 1 hour written, means after 1 hour, even if you see, the ball will stay at its own position.
Okay.
Done, ma'am. Okay, now see the next topic, which is momentum. Now, momentum means the amount of motion which is left in the body. Suppose a vehicle is moving, right? Very, very fast. Or let's take the example of vehicle. Let's say a block is there, wooden block is there, and a bullet has been shot. Now that gun has been shot and the bullet is moving very fast and it goes into the block. It penetrates into the block. Now it should have stopped. But now, since there is so much momentum present within the body, so much momentum is present in the body, that means the amount of motion is present within the body, that body tends to move forward. Alright, the body has a tendency to move forward, further forward. So block also gets displaced, bullet also moves. So this amount of motion which is residing, which is left inside the body, is called momentum. It is represented by this symbol P. It is equal to M into V. V is velocity. All right. So see, what are all these terms? P is the momentum. M is the mass. And V is the velocity. So we can say it's basically the product of mass and velocity. It's a vector quantity and direction is same as that of velocity. And what will be the SI unit? Mass is kg, velocity is meter per second. All right. Like, look at this example. A body of mass 10 kg is moving with a velocity of 5 meter per second. Mass is 10 kg, velocity is 5 meter per second. You have to calculate the momentum. It is 10 into 5, which is equal to 50 kg meter per second. Simple. Like this only you have the concept of momentum. One thing, when the momentum changes, inertia changes. Obviously, if lots of momentum or lots of motion is left within the body, it had to stop, but now it continues to move. So it changed the inertia state, right? And external force in such cases become zero. So please write the concept of momentum. It's important.